Assalamu alaikum and welcome back to my YouTube channel. In the previous video, we discussed autoencoder structure, their working, and the different types. We saw how using unsupervised learning, autoencoders try to reconstruct their own inputs. In this video, we are going a step further and taking the black box out of the autoencoders. We will manually run a forward pass on a simple undercomplete autoencoder to understand the encoder compression, the decoder reconstruction, and the error. We are using an undercomplete autoencoder with 4 inputs and 4 outputs and a hidden layer with 2 neurons. Our input vector x has 4 values 1, 0, 0.5 and 1, and our target output is the same. We will be using sigmoid activation for the hidden layers and linear activation for the output layers, and the loss function would be mean squared error. The weight matrix between the input and a hidden layer would be of size 4 cross 2, and the weight matrix between hidden and the output layer would be of size 2 cross 4. Here are our initial weights and bias for encoder and decoder. Encoder has a 4 cross 2 weight matrix and 2 bias. That's because we have 2 hidden neurons. The decoder has 2 cross 4 weight matrix and 4 biases because we have 4 output neurons in the final layer. All bias values are set to be 0. In the phase 1, we will do the computation for the encoder, which is called compression. First, we will compute the linear combination Z by multiplying input with the weights and adding the bias. Next, we will pass this Z to a sigmoid function and compute H. This H would be the input for the decoder. Let's put the values in our equation. X is the input vector. Then we have the weight matrix for encoder and bias for the encoder. By multiplying X with the first column of weight matrix, we get Z of H1. And by multiplying the X with the second column of weight matrix and adding the bias, we get ZH2. Combining them, we get ZH equals to 1 and 0.55. Now we will pass this Z to a sigmoid function. Sigmoid is 1 by 1 plus e raised to power minus Z. In place of Z, we will put the values 1 and 0.55. Now we get the H, which is 0.73 and 0.63. This H is our hidden compressed representation that will become input for the output layer. In phase 2, we will do the computation for the decoder, which is the reconstruction part. Since the activation is linear, we will only multiply the hidden values with the weights and add the bias. Let's put the values into the equation. H is our compressed hidden input, WD are the weights for the decoder, and BD are the biases for the decoder. After computing it, we get Y hat, and the values of Y hat are 0.73, 0.507, 0.219, and 0.463. So now we have computed the hidden representation as well as the Y hat. The next phase is to compute the reconstruction error. We will use mean squared error, and the formula is 1 by n summation yi minus y hat squared. So we will take the difference of actual y and the predicted y and take their square and then sum them. After that, we will divide by n. N are the total number of values. In this table, we have the true y and the predicted y, and then we compute the error by subtracting the true y and the predicted y. After computing the error, we compute the square of the error. We do this for all the values. At the end, we compute the sum of the squared errors, which comes out to be 0.69. Now we put the summation of y minus y hat squared into the equation. 1 by 4 multiplied by 0.696. So the mean squared error or loss comes out to be 0.174. Now we comes to the end of the forward pass. We compressed the input, reconstructed it, and then computed the reconstruction error. In the next video, we will do a step further and do the backpropagation. If you found this video helpful, please like, share, and subscribe for more videos on data science and AI. See you in the next video.